The backfire effect is when you present people with information that contradicts their beliefs. They often end up, instead of changing their minds to be more in accordance with the evidence you gave them, their initial wrong beliefs gets even stronger.
Hello everybody and welcome back to Chasing Consciousness. I hope you are all well. Today we have the fascinating job of trying to understand how easy it is to change our beliefs when we receive new information. A process that, as we will hear today, can be really quite uncomfortable and lead to a lot of resistance in the psyche. The scientific community, whilst educated to do exactly this, to update their worldview based on new information and proven theory, are by no means immune to this resistance. And so today, I hope we're going to find out to what extent it really is just a human trait, or if it could vary from individual to individual. And perhaps even our mindfulness could improve. So for me, seeing the natural democracy of science, where experts argue over the implications of data and the appropriate course of action until they reach a consensus, has, for me, always been one of the most beautiful aspects of the progress of science. And now that the scientific method has become more watertight from our biases than ever, and data collection is more sophisticated than ever, in theory, the difference between hard data on the one hand and the opinion we draw from that data on the other should also be more clear. However, I fear it is not. The introduction of the internet and the separation of the population by social media algorithms into these tribal bubbles of like-minded people who listen only to each other has really mixed together data and opinion, confusing both the scientific community and the lay population alike. So perhaps understanding the biology of belief, our discomfort and our resistance to new information, and how beliefs play such an important part in our sense of self, perhaps that can really help us to stay open to new data and to update our worldview to match it, with the necessary flexibility that seems to be demanded by the just sheer speed of change of our current era's technological revolution. And in my opinion, this awareness really offers essential tools for navigating the next few decades. So who better to help us navigate this minefield of human behavior than cognitive neuroscientist Dr. Jonas Kaplan. His research focuses on the neural basis of consciousness, self, empathy, social relationships, action perception, and creativity. And using a combination of fMRI, neuroimaging, and behavioral studies, he aims to examine the neural mechanisms that underlie our experience of both resonating with others and also being aware of ourselves. So very, very relevant to this question. He's the assistant research professor of psychology at the University of South California. And he is also the co-director of the Dana and David Dorn's Live Cognitive Neuroimaging Center. In today's chat, we're going to begin focusing on his research with Dr. Sarah Gimbel and Sam Harris into a possible backfire effect when faced with new data, which we'll define in just a minute. So don't worry if you haven't heard of that. In this time of massive polarity and controversy in our information ecosystem, this research is so important for our sense-making and our mindfulness that I just couldn't wait to speak with Dr. Kaplan. So without further ado, let's go. So hello there, Dr. Jonas Kaplan. Thank you so much for joining us on Chasing Consciousness. How are you?
I'm good, Freddie. Good to be here. How are you doing?
Well, I'm good. I'm really, really grateful that you've taken the time out of your busy schedule at the University of South California to join us. Jonas, just before we get into the main topic of your research on this very important issue of how we update our beliefs based on new information, tell us a little bit about the arc of your career so far, and perhaps what you were curious about in the first place that led you into neuroscience and psychology.
Yeah, well, I think curious is the right word to ask about, because to me, curiosity has definitely been the driving force in my career, and I've just tried to follow that as much as possible. And the thing that I've always been curious about is consciousness. You know, from the time I was a little kid, just thinking about my own mind and how it is that our conscious experiences all depend upon a piece of flesh inside of our head.
Yeah.
Has always been to me just the biggest mystery in the universe. And so that's what's driven me. And when I first went to graduate school in psychology at UCLA, my intention was to study consciousness. And I worked at UCLA with my mentor there was Ron Zeidel, and he was studying the split brain. We studied the differences between the left and the right hemispheres, but also the split brain situation. This is a case where people have surgically separated the two hemispheres of the brain as a treatment for epilepsy. It was as if they had sort of two separate consciousnesses in one head. So it was for us a way to study the problem of consciousness. And from there, my research just evolved. I constantly followed my curiosity. I always circled around issues of consciousness and self. That's where I went. More recently, my interest in self has taken me to an interest in the identity of how we conceive of ourselves, what the story of ourselves is, and that is connected with our beliefs and values. And so the work we've been doing on the neuroscience of beliefs and values, for me, is connected to the study of the self and the study of consciousness.
Fantastic. And we will definitely be going there today, won't we, Jonas? And also, just to let you know, listeners, that we are also going to be covering the extraordinary arc of research into left and right hemisphere research and the various opinions about that across the spectrum. Well, listen, let's just cut straight to the chase, Jonas. What is this backfire effect? If I understand correctly, this is something that you have come out with, your laboratory has come out with. What exactly were you setting out to prove, and how did you set up the experiments to get there?
Okay, so we did not discover the backfire effect. This is an effect that's been around for quite a while. Some of the earliest research on the backfire effect was regarding vaccines and anti-vaxxers, and why people have such really fixed beliefs about vaccines and can't take in new information. So what is the backfire effect? And let me clarify a little bit, because much of our research is related to the backfire effect, but doesn't focus on that effect particularly. The backfire effect is when you present people with information that contradicts their beliefs, they often end up, instead of changing their minds to be more in accordance with the evidence you gave them, their initial wrong beliefs gets even stronger. So in the case of the anti-vax studies, what the research found was that giving people information about the safety of vaccines and the efficacy of the vaccines in preventing disease and the safety of them actually made people, in some cases, have more strong anti-vaccine beliefs. That's why it's called the backfire effect. It's like a paradoxical effect. Somehow arguing against someone's position makes their initial position stronger. It's like people just kind of double down on their original beliefs and make them stronger. And the idea is when you're challenged, you feel threatened, and it's not a good feeling. We don't like to feel threatened. And in order to make ourselves feel better, we work to shore up our initial beliefs, and they end up being stronger. So that's what the backfire effect is. Now, my lab has been interested in a more general phenomenon, which is just that it's really difficult for us to change our minds, right? When we encounter new evidence, particularly about things that we care about, it's very unusual for us to just say, oh, okay, I was totally wrong, I guess, and change our minds about things that we care about. So the resistance to evidence is really what we're studying. The backfire effect is one form of resistance to evidence, but it's not the only form. And in fact, in many of our studies, we don't really see a backfire effect. Backfire effect has become somewhat controversial since the initial studies. There's a lot of researchers who have tried to replicate that result, haven't found it. And so we don't really understand in what cases does the backfire effect occur, and what cases does it not occur.
Can you give us some other examples, Jonas, some other examples of other kind of areas apart from the vaccine issue?
Yeah, there are a lot of things about health. You can study things, give people information about various health information. You give people information about politics, and any kind of wrong belief can be corrected. And it's difficult to correct those beliefs. The backfire effect is not the entire problem. The bigger problem, in my view, is that it's just really difficult for us to change our minds. Why do we not take in information about things that we care about? And this seems like a hugely important issue because, first of all, there's the progress of science. We're always learning new information. We want to be able to change our beliefs just because we gather new data. But more generally in society, we have this view of a democratic society working on the basis of conversation where we discuss things and we change each other's minds and we come to some kind of consensus. And if we're not able to influence each other and there's no way for us to take in new information, we end up deadlocked and we're at a standstill. And that's a really dangerous thing for us to be completely locked into our beliefs. So we set out to understand why it's so difficult to change our minds.
Right. And can you just give us an example of the way an experiment would be set up? Because I imagine it must be incredibly difficult with these quite subjective issues to get really, really, as you say, repeatable statistics and repeatable results. Give us an example of one experiment.
Yeah, so we did an experiment to try to understand the neurobiology behind why we don't change our minds. So I am a cognitive neuroscientist. I study psychology by understanding the brain, because the brain supports all of what our mind does. And so we use brain imaging technology called functional MRI. And this allows us to watch what's happening in the brain to measure changes in brain activity as people do different psychological things.
Sure.
So in one experiment that we did back in 2016, this study was published, we looked at why it's so difficult for people to change their minds about things that are important to them. And we chose the realm of politics. We decided to argue against people's political beliefs because political beliefs tend to be very strong. It was easy to find people with strong political beliefs. And you can make arguments against people's political beliefs. We should be able to argue about politics. There's some other realms where people have really strong beliefs, like religion, where it becomes more difficult to form arguments about what they believe because they don't even claim to have a rational basis. So politics was a good place for us to start. And we found people that had really strong political beliefs. In Los Angeles, those people tend to be liberals. So we gathered a sample of very strong self-identified liberals who had very strong political beliefs. And we identified a set of beliefs that they endorsed, that they said on a scale of 1 to 7, I believe this, a 6 or a 7. It's like a really strong belief for me. And they could be, half of them were political beliefs, things like taxes on the wealthy should be increased.
Yeah.
Or, abortion should be legal. And half of them were non-political beliefs, but things that they believe just as strongly. So it could be Thomas Edison invented the light bulb,
Yeah.
or multivitamins are good for one's health, something like that. And once we put them inside the fMRI scanner, we showed them these statements, and then we showed them arguments against their very strong positions. So with Thomas Edison, that's a fairly easy one to debunk. There's a lot of information. For example, Thomas Edison's patent was invalidated many years later. There are some similar devices that other people invented earlier. Edison took credit for lots of things that were done in his laboratory that maybe he didn't deserve credit for. We present these arguments to people, and then we ask them, okay, now on a scale of 1 to 7, how strongly do you believe that Thomas Edison invented the light bulb? And then that gives us a measure of how strong their belief is after seeing the evidence. We can compare to what they said before, and now we've got an idea of how much they changed their mind. What we can do with the brain imaging is then look into the brain to see what's happening when people really resist changing their minds, when they have that kind of stubborn resistance. What happens when they do change their minds, when they're more flexible and they give way? We're able to make those comparisons. We could also ask things like, well, what is it like thinking about when your beliefs are challenged on something you care about, like politics, versus when it's something you don't care about, like some scientific fact that you're just not invested in. And that allowed us to look at some of these mechanisms from the inside out. That's what we're trying to do with brain imaging.
Was there anything interesting that you noticed on people who were more flexible or less flexible in the brain imaging?
Yeah, so what we found when we compared those kinds of people is that there were differences in specific brain areas that mostly have to do with emotion. Now, this is a simplification because whenever we talk about brain regions, it's a simplification to assign one single function to one particular brain region. But for example, we found that activity in the amygdala and in the insular cortices were correlated with how flexible people were. So the more people activated these brain structures when they were being challenged, the less flexible they were. And these are brain structures that do support emotion and feeling.
And amygdala is about danger, isn't it? It's about emergency. So there's a sense that I'm being threatened, and therefore I kind of, that's leading to a cognitive block.
The amygdala is very important for threat. That's right. I mean, it also does tend to respond to other emotions as well. So it's not only threat, and it probably has a more general function that has to do with detecting emotionally salient things in the environment.
Ah.
But that is one interpretation, that there's something emotional happen. There's some kind of threat to us. We're feeling something. And the more we feel those negative emotions when we're challenged, the more we just want it to go away. We don't want to deal with the information. We want to get away from it. And actually getting away from information is one of our best strategies for maintaining our beliefs. One of the things that we do best is to avoid being in situations where we're going to be challenged. We do that by selectively reading things on the internet. We do that by choosing people to associate with who all tend to agree with us.
We are definitely coming back to this, Jonas, because this is right at the center of the sort of 2020 post-social media world, isn't it?
Right.
And what about the people who are more flexible? Is there a suggestion that this sort of the amygdala side, the resistance side, the just get out of there rather than change your belief side? Is there a sense that maybe those people might have, I mean, it's probably a whole nother set of research, isn't it? That those people who are more sort of amygdala prone, that there might be a history in them somehow of having been threatened in the past. Is there a trauma connection here?
That's certainly possible. It's not necessarily the case. I mean, there are many, many different reasons why these different patterns of activity could arise. It could be experience-based. It could be genetics. We know, for example, that in our study we only studied liberals, but liberals and conservatives differ in terms of their neural anatomy. We know that the amygdala can be larger in conservatives, for example.
No way.
Yeah, and there's also evidence that conservatives tend to activate their insular cortices more. So we don't know where these differences come from, but they're there, and they definitely are part of what makes us all different.
So the more flexible people, tell us a little about the brain imaging with them, people who are willing to update their opinions and their beliefs.
Yeah, so these people showed less activity in those emotion brain regions. One of the things that we should be careful of is not to put a value judgment on whether or not it was better to change your mind in these circumstances.
Good
right?
point.
So
very good point.
You could say that these people were more mentally flexible, or I could say that they were more gullible. And right? It's hard to know exactly where the right balance point is for what you want. You don't want to be completely stubborn such that you can never take in any new information. But you also don't want your mind just swaying with the wind. Every new piece of information that comes along, you accept it, especially, as you say, in the situation with 2020, where we have so much misinformation spreading around the internet. And it's important for us to have filters to be skeptical of information that we encounter. So we probably want to find some kind of middle sweet spot where we've got some degree of skepticism and our models of the world are stable. They're not changing with the breeze. But on the other hand, we're not completely shut off to new evidence, and our beliefs are completely fixed.
I'm also really interested in this, the fact that you said the emotional centers were being more stimulated in, shall we say, the more stubborn subjects. Would you say that as those emotional triggers are causing resistance, we're actually taking part of the frontal cortex offline, or is that a simplification?
I think it's a simplification, and it's worth pushing back against that view a little bit for the following reason. So first of all, we have to recognize that emotion and cognition are completely intertwined. I mean, there isn't any separating. We can talk about them in terms of levels that we see in evolution, but in our own brains, there really is no separation between emotion and cognition, and we probably don't want there to be. So it's easy to think of emotion as the enemy of rationality. But it isn't really. First of all, emotion is life's oldest system for keeping us alive. And remember, the brain's job originally is to make sure that we're alive. The reason we're so smart is because we're clever at keeping ourselves alive and maintaining the homeostasis of our body, keeping ourselves within the right temperature range, getting food when we need it, being able to hunt effectively. That's what all these systems are for. And emotion is incredibly intelligent. Emotion is what kept life alive for billions and billions of years. And these newer systems of rationality that we have, where we are able to suppress emotion, and sometimes it's effective to do that, are always informed by emotional processes. And we one of the things we can look at is cases of brain damage where certain parts of the frontal lobe are destroyed that help us to incorporate emotion into decision making. And what happens when you damage those brain regions in part of the prefrontal cortex we call the orbital frontal cortex, or the inferior medial parts of the frontal cortex, is that people make very bad decisions. It's not like they become hyper-rational robots. They don't turn into Commander Data or Spock or something like that, where they're just, completely rational. They're actually quite irrational because they can't use those feelings to guide their decisions. They tend to take incredible risks, for example. And they do things in their lives that most people don't do because we have a feeling that that's not the right thing to do. So these feelings and emotions are always informing our cognition, and we shouldn't think of them as the enemy. That said, there are times when it benefits us to be able to suppress our emotions. And one of the things we're looking at now in our research, since this emotional activation seems to be so important in the process of taking in information, we're asking the question, if we get better at regulating our emotions, does that make us better able to take in new information? If I feel that negative feeling when I'm challenged and I'm able to separate from it, does that allow me to be more flexible in my cognition? So one of the research questions we have right now is if we train people in emotion regulation or mindfulness, for example. Mindfulness meditation is a process of training the mind to become more objective about your own thoughts and feelings and to separate the kind of habitual thoughts that you have from the feelings that you have. And if people can learn to do that, maybe they can be more flexible.
That's interesting, isn't it? We're definitely, listeners, going to be looking into the neuroscience of meditation on the show. There's lots of studies that talk about an improved cognition for long-term meditators. But also, I sense, and there's something we're going to be looking into the show, sorry to come back to the trauma issue, is that what we see really is the compromised nature of the frontal cortex happens when, as polyvagal theory talks about, when our emotions push us out of a certain sort of limit of the ability to function normally into an altered state, if you like. So do you have anything to say about that? I mean, obviously that's not the topic of our conversation today, but I just feel that it is relevant for reasonable thinking.
It's definitely relevant. I mean, I don't know about the trauma part of it per se, but certainly the craving of safety is a lot of it. Again, the brain is really its main concern is to protect us. And I think the interesting thing one of the interesting things that comes out of our research is that the self, if you think about what the self is, what is the brain actually trying to protect? What is the self? How does it define us? It's a really interesting biological and philosophical question. But from a biological perspective, one might think that the self that the brain is trying to protect is the body. Right? It's, wants to keep my body alive. But I think it's more than that. What happens is that our psychology and our psychological self becomes one of the things that the brain thinks is worth protecting. And that's why when our beliefs are challenged, beliefs that become part of ourselves become protected at a much greater level than beliefs that aren't part of ourselves. I think that's why we see...
I definitely want to come back to this because I know you've done a lot of research into the self itself. Yeah. So before we come on to that, I want to take a few sort of steps to get there. The first important one is a similar idea that unfortunately with my extremely amateur brain, I can't understand. I wanted to ask about cognitive dissonance. Now, it's a bit of a buzzword these days, again, because we live in such a polarized society. Cognitive dissonance is given as a kind of an excuse for refusing to accept facts or refusing to incorporate people you would naturally disagree with when they're bringing forward verifiable facts and new information. What is, if any, the difference between cognitive dissonance and the backfire effect as far as you know, and how do they function? Do they function in a similar way or are they just the same thing?
Okay, so cognitive dissonance is a state of conflict. It's a state of conflict between our beliefs and our values and something else that we detect in the world and often within ourselves. So, for example, if I want to eat healthy and I find myself with an Oreo in my hand, I've got cognitive dissonance, right? And then I find I've taken a bite out of that Oreo. Now I have this belief that I want to stay healthy, and I have my action that I just took a bite out of this Oreo, and there's a conflict there. And that's cognitive dissonance, and is associated with a negative feeling. It's another place where emotion enters into the process of cognition here.
And self-judgment.
And in that case, self-judgment, yes. And it doesn't feel good, and we don't like it, and we want it to go away. And because of that, since we're motivated to make that feeling go away, we go through all kinds of mental hoops to make it go away. And there are lots of different ways we can do that. We can try to, paper over the fact that, it was only one bite, or, Oreos can be part of a balanced diet, right? Some kind of rationalization. This is an example. Cognitive dissonance is an example of one of the motivators of reasoning. And I think there's the general topic to be aware of is that our motivations color our reasoning. And cognitive dissonance is one of those potential sources of motivation, which can cause then a backfire effect, right? This is one of the potential causes of something like a backfire effect, or at least a resistance effect, where we try to resist the new information because it doesn't feel good to have that inconsistency between our belief and what we're encountering out in the world. But I think it's important to recognize that this is just one of many motivations we have that colors our reasoning. We could have all kinds of motivations. We could, as scientists, for example, we're not immune to motivations. All scientists are also people, at least so far. And we want things as well. We want to be right. We want our careers to succeed. We want to get research grants. And all of these things are motivations that can color your reasoning when you're taking in new information. And so I think that's the main thing, if you're trying to be a more objective reasoner, is to be aware of all of the different motivations that could possibly color your reasoning.
And I wonder how much, particularly in psychology, it's important to qualify that in your introductions to your papers. It must be so difficult, because if you start going there, it slightly undermines the value of your research. We have also, listeners, got a show on the experimenter effect, and it has, for a long time been a big issue in science, this idea of scientists setting out with an objective that they are hoping to achieve with their research, and that obviously coloring very much the way they look at their data. What's your do you have a kind of code book, a personal law of ethics for making sure that you don't do that, Jonas? What's your take on that, the experimenter?
Well, the first line of defense is science itself. So, what science really
method,
is a method for trying to separate out the effects of these motivations from what we learn. It's obviously not a perfect method, because our motivations are very effective at sneaking into these things. But if you think about some of the technology of science, something like a double-blind study is designed explicitly to deal with these kinds of experimenter effects. So if we know we have these motivations, and that as experimenters we can affect things, if we remove the knowledge of which condition this person is in, are they getting the treatment, are they not getting the treatment, then that knowledge can't affect things. So that's an example of a procedure that we put in place to try to counteract one of these motivations. There are procedures that are embedded within individual experiments like that. And then there are procedures that are embedded within the overall process of science over time, where we try to replicate experiments and we criticize each other. And there are consequences for faking data, for example.
Yes, right.
So we try to build in all of these things. And obviously it's not a perfect system, because it is a human system. But I think it's important to recognize that the reason that we implement all of these scientific procedures is just that. It's to try to counteract those motivations that we know we all have.
Well, we're going to come back to this shortly as we go back into the left hemisphere and the left brain interpreter. But let's stay with the backfire effect just for a moment, and let's get a little bit more philosophical rather than thinking about the data. What are the implications for this? I mean, it's always existed. We've always had biases. We've always had a resistance to changing our minds. Conservatism has always been there. Consensus has always been many years behind experimental new ideas that turned out to be true. What are the implications for this, in your opinion? And well, perhaps why did you think it was so important to study it?
We've been studying the neural basis of belief for some time. We studied, this is some work that I collaborated with Sam Harris a while ago. We had studied the neural basis of religious belief. We'd studied, is it different to believe something when it's a religious topic versus a non-religious topic? We found that it wasn't. And
it
then
wasn't,
when
it wasn't, you said?
It really wasn't. I mean, in terms of deciding what's true and what isn't true, the brain seemed to be doing the same thing, whether it was deciding about God or about Santa Claus.
And was Sam, who's sort of famously atheist, was he sad that they weren't different in the brain? Was he disappointed with that result?
No, I don't think so. In fact, it corroborated something he had been saying for a while, which is that when people say that they believe in God, you have to take them seriously because they really believe it in a very similar way to other beliefs that we have about the world.
Oh, that's a beautiful thing to say. That's nice.
Yeah. And when Sam and I were thinking about what the next most important topic was in belief, we just came to this idea of, it's just, we spend so much time talking about things that we think are important. And we spend so little time actually seeing positive effects from that, seeing people really change their minds in front of our eyes, that understanding why that doesn't happen has to be the next most important thing. Right. And at the time we started talking about that, it was maybe 2012 or so. And this really wasn't a topic that was on people's minds. Right. I think it's sort of hard to imagine now because it's really on everybody's mind now.
Well, the Jordan Peterson explosion and all of this highly controversial, what do they call it? The dark web, and all of these people getting into all kinds of sticks and struggles over these very controversial issues, which really actually, when it boils down to it, are often a matter of belief and not of fact.
There's been that, and there's been the whole sort of political phenomena that have happened since then. And you ask why this is important, given that these things have always been in place. These psychological processes have always been there, and we've always had cognitive dissonance. It was true. But I think there are some reasons why this is more of a problem now at this point in history than it has been at any other time in history. And a lot of those have to do with the internet, of course, and the way information flows on the internet. We have basically erected these technologies which we thought would connect us with more people and more information. And effectively, what they end up doing most of the time is connecting us with information that confirms what we already believe and separating us from people who don't believe what we believe, creating echo chambers.
Algorithmically, in many cases, never mind actually purposefully, but actually by an AI.
Exactly. And I think also because of that, one of the things that has happened is that we've strengthened our little sort of micro identities. All these different groups that we belong to have become more important to us. One of the things that we think belief does, one of the functions of it, if you think of why do we believe things about the world? It seems almost like a stupid question, because obviously you believe things in order to know things about the world, in order to have mental models that you can then interact with the world through. That is definitely one of the functions. It may not be the main function of belief. One of the other things that belief does is to bind us with other people.
Belonging, I was going to say.
Belonging. Yeah. We want to share beliefs with other people. It feels good to share those things. And we have these shared mental models. We can all act in a more coherent way. And that's why, often changing your mind involves changing a lot more than just your mind. It involves changing your whole social life in some cases, if something's important to you. And one of the things that has happened is that as we become more closely connected with all the people that share our beliefs, this bonding effect has become stronger, and it's become even more difficult for us to change our minds.
Kind of tribalism.
Yeah, tribalism has become more at the forefront. I mean, tribalism has always been part of us, of course. But there's a way that the tribalism is now sort of connected through the information flow. We kind of mainline it through Twitter and Facebook and all of these places where we're constantly fed information and emotions that resonate with what we already believe. That makes all these effects stronger.
So you've just said it. That's where I wanted to go, was that you say that makes these effects stronger. I mean, I'm thinking of echo chambers here. I'm thinking about, just let's talk a bit about the post-social media world, which sadly really has had such an enormous effect on culture. And because it's a young phenomena, I don't think that neither the commentators nor the psychologists nor the public themselves have had a chance to let it sink in enough to be able to sort of self-criticize. echo chambers, this sense of sort of confirmation bias, polarization, the fact that we are so triggered by anything that comes into our echo chamber and our confirmation bias with something opposite, that it's kind of immediately bounced away with a reaction before anyone's even had a chance to think about it. There's a lot of amateur journalism. I've got nothing against amateur journalism, but fact checking is becoming harder and harder because the internet is such a resource for facts, and therefore it is very, very easy for journalists to not be looking to actual people and actual sources for information, but finding digital resources. These are just a few features of this post-social media world. Do you think the implications of the backfire effect are really important here? And I mean, is there a mission of awareness here? Why is this effect so important now? What are the implications for maybe trying to curb some of these issues, if they are indeed as out of control as they seem to be?
They certainly seem to be out of control, and I think everything you said is correct. And in a lot of ways, we've become experts at implementing our confirmation biases, right? I mean, a lot of these algorithms and these technologies and the culture that we've built online has sort of amplified our confirmation bias and a lot of the sort of motivated reasoning that we have, rather than done the opposite of that. And so, what is the solution to this? Is you mentioned awareness. I don't know that awareness is enough. I don't think that simply being aware of our motivations and our biases makes them go away. I mean, you can know that you can study the confirmation bias all you want, but then the next time you go to the internet to find some information about your favorite political candidate, I mean, you're going to search out the good stuff and ignore the bad stuff still. And that's not to say that it's futile. It's sometimes when people learn about these things, they will make an effort to expose themselves to different kinds of information. But I don't think just being aware and knowing about yourself is the solution. I mean, psychotherapists know this very well. It takes
they often
retraining.
say it's 50% of the problem. It's 50% of the journey, isn't it? But it's only the beginning of the journey, because it just opens the door and sheds light on the situation. But you did mention meditation and mindfulness. I mean, let's think of this at a neurological level. Presumably, the difference between the amygdala's very, very instantaneous neural reaction and the frontal cortex starting to come into play a few seconds later, if we can just be aware of that, surely that's an amazing tool to help ourselves take a step back and keep an eye on what is pure reaction, what is pure emotion, and what is actually something that has been reflected on looking at various possible inputs.
Yeah, that's right. But I mean, meditation takes practice. It's not just a realization. It's you have to retrain your mental habits in order to be able to do that. The other thing that is interesting with meditation in relation to our work is that one of the things that we find when we look in the brain, when people are challenged about something that they care about, something that's related to their identity, like politics, compared to other things, that we see this increase in this one particular brain network. It's a very interesting brain network, and as neuroscientists, we're just beginning to understand exactly what it does. It's called the default mode network. It's called that because, have you heard of it?
I've heard of it in relation to intuition, yeah.
Yeah, it tends to come online when we're just kind of daydreaming and mind wandering. But in fact, it's also a brain region that's very important for processing our self and our self-narrative, our kind of idea of our personal story, our identity. And that's why it's interesting that it comes online when these identity-related beliefs are challenged. The reason I bring it up now is because one of the things we see in meditators when they practice meditation long-term is that we see decreases in this default mode network activity. Because this constant interpretation, you mentioned the left hemisphere interpreter, I really think it's probably more like the default mode interpreter that we have. This constant story making and meaning making in language and narrative form that we do with ourselves is part of one of the things you kind of untrain with meditation. You learn to, with certain kinds of meditation at least, you learn to just experience the experiences as they are and to not add on the whole level of interpretation and rumination and narration. And I think those narrative processes we have in the brain, particularly when they're applied to ourselves and our understanding of ourselves, are part of the problem here. And if we can learn to separate ourselves a little bit from the information we take in, and we learn to kind of quiet down that self-narrative, that constant autobiographicalization of everything, then we might have part of the solution there.
And that sounds a bit like the scientific method itself, doesn't it? It's almost like making ourselves into a scientific method machine, because we're taking ourselves out of that dynamic and allowing the facts to pass by, as all these meditation techniques talk about, just watch it passing through and don't judge it. That would kind of, I suppose, be the ideal way to deal with new data.
Yeah, you have some objectivity with respect to yourself, basically.
Yeah. What else, though? You mentioned that the awareness is maybe, we spoke about psychologists talking about it sort of 50% of the battle. What else, apart from skills of mindfulness and meditation, what other things are implied from your research in terms of what we might be able to propose to the world to try and sort of, as we say, just bring down the extraordinary power of these echo chambers and these polarized confirmation bias situations?
Yeah, I mean, the first thing to say is that we really don't know. I mean, this is a huge problem, and I don't think we have good solutions yet. We have a lot of ideas that need to be tested. One of the things that we think a lot about is because people's beliefs, the real difficulty comes in talking about beliefs and values that are really, really important to us. And one of the things that we've studied is the concept of sacred values. So this is a concept from the psychology literature that some values become so important to us that we think about them in a totally different way. Many values that aren't so important to us have a sort of utilitarian nature to them. We can think about them in terms of cost-benefit analysis. So, for example, I like to use a Macintosh computer, not a Windows computer. That's a value that I have. I think the Mac operating system is just much better. I prefer it. But there's some cost-benefit analysis. If the Mac costs $5,000 more than the Windows machine, I might consider buying a Windows machine. Actually, I think the difference would probably have to be more in the $10,000 range. But there is some price that I would pay to change my mind on that, or to make a different choice. But then there are some values that completely transcend that kind of cost-benefit analysis. We're not thinking about them in terms of any kind of trade-off. Things like the protection of children. If you offered me some money to take my daughter, there's no price there, right? You can't take my child away. It's just the principle of it is completely even taboo. We won't even think about it. So it turns out that these values are special. They're special in terms of the way the brain works around them, and they may be at the crux of a lot of the most difficult issues that we deal with. So if you think about political conflicts, things like the Israeli-Palestinian conflict, if you're fighting over a piece of land, that's one thing. Land is a utilitarian thing. It has utility. You can use it for something. It has a value. I could pay you for it. But when it becomes sacred land or holy land, then there's a principle involved. And then we're not just fighting over something that has some kind of material value anymore. And now we've got a problem where we're going to be fighting for thousands of years. So I think it's really interesting to think about how to deal with these kinds of sacred values, these protected values that are the deepest and most important things to us. And how do we communicate with people who share different values when those values are so important to them and so different from what we believe?
Did you find any different areas of the brain firing when you got close to these slightly more untouchable, sacred, taboo values?
Yeah, and it really is that default mode network again. So we found that when people read stories, for example, that have those values embedded in them, that are about those kinds of values, that they show increases in activity in that default mode network.
So it's a kind of vested interest. It's this thing, it's so closely connected to me as a self, I start to lose the ability to have a wider perspective.
Yes. And when you try to have a utilitarian discussion with someone who has a sacred value, you don't get anywhere, right? So if you start to tell me we're having an argument about the death penalty, and for me, this is about the principle of protecting life, you just can't violate. And you're talking about the costs and benefits to society, it's going to decrease the number of prisoners or the cost, the amount of money we pay. That's not going to make any headway. So a lot of times these conflicts that we see have to do with these sacred values, and I think it's really important for us to figure out a way to communicate about them.
And do you think then that it's not so much a question of whether those sacred values are good or bad or causing problems, or improving the situation. It's more a question of just working with them in a really knowledgeable way to make sure that they're included in this conversation, in this understanding.
Yeah, that's right. And so one way to do that, and this is something we're looking into more now, is to frame your communications in terms of the values that are important to the person you're talking to, right? If you can understand what the values are that underlie the other person's position, and then frame your arguments in a way that appeal to those values, you might have a better chance at actually making some headway.
So there's a sort of an empathy issue there. There's a sort of think about who you're speaking to. Gosh, that's absolutely fascinating. Listen, I just wanted to go into this left brain interpreter momentarily before the break, Jonas. We're speaking to Dr. Mike Gazzaniga. I'm sorry, I may have the pronunciation of his name wrong there. I think
Gazzaniga.
Gazzaniga, yeah, I always get that one wrong. Dr. Mike Gazzaniga, who was one of the original pioneers in the split brain experiments about this extraordinary phenomena of the left brain interpreter. The phenomena his team discovered where explanations are just created by the left hemisphere of the brain by reconciling new information with what was previously known, sometimes completely falsely. I mean, even extraordinary things like thinking that a limb that's attached to their body actually belongs to the doctor, for example, or something quite extraordinary like that. So following your research, Jonas, I mean, what we knew before, I mean, that could just really just be a deeply ingrained bias. So we may all be supporting invented explanations just to fit with our current worldview rather than updating our beliefs based on new data. I mean, how does this bode for the future of the scientific mission for objective truth, but even worse, for the future of trying to combat this culture of disinformation?
Yeah, well, I think it undermines the important need for science. Part of the reason we need science so badly is because of all of these underlying motivations. So the one you're talking about, where the brain really seems to have this strong motivation to make a coherent story out of everything, to the point where it will confabulate in order to make consistent explanations for a thing. I mean, it's really amazing. We see this in all kinds of brain damage. For example, there are cases of certain kinds of amnesia where instead of admitting that, I don't remember what happened yesterday, the brain will make up some story that seems plausible, but isn't true at all, just to kind of paper
really
over.
Creative, though. I mean, it's a fascinating phenomenon because it's so creative. You wouldn't expect that coming out of the center of the left hemisphere with its very isolated kind of take on things.
Well, the brain is doing this in all kinds of ways at all times without us knowing about it. So let me give you another more perceptual example.
The eye.
Yeah, exactly. Everything we experience in a lot of ways is a construction of the brain. It's an interpretation of incoming information. And the blind spot in the eye is a great example of that. You have a spot at the back of each eye that doesn't receive any information about the world because there are no photoreceptors there. Yet when you close one eye, there's no hole in your vision. You don't see a gap in the world. Your brain fills that spot in, and it fills it in very cleverly. It fills it in with all the stuff that's right around it, right? It's kind of like a Photoshop content-aware filter. If you're looking at a bunch of rocks, you see more rocks there.
Yes.
So this conscious perception that the world is presenting to us is a construction. It's a kind of a hallucination in a way. And it is constrained by reality. It's not completely made up. Reality certainly influences it. But a lot of what we perceive comes from our sort of top-down hypothesis testing about the world and not from the actual data in the world itself. It's not like we have some pure perception of reality in any sense. We're always making interpretations of the world.
And so just to come back to the left hemisphere, the left brain interpreter phenomenon again, is there a risk of us actually completely deluding ourselves? I mean, is there, this isn't just about cognitive dissonance or about the backfire effect, because of course, in both of those cases, the information remains there as a sort of, kind of, it could stay there slightly troubling us like a little sort of demon on the shoulder going, but you remember that thing that you read the other day? Whereas the left brain interpreter can just literally completely make it up. And you can wander on through your life like everything's fine. I mean, is this is this actually happening in the world, that there are people out there living in a completely deluded reality based on this left brain interpreter sort of building on top of cognitive dissonance and the backfire effect?
Absolutely. I mean, certainly delusion is out there, and it's not just. I just want to say it's not just the left hemisphere. I think that Dr. Gazzaniga's influence on there his insight there was really important, and it was amazing that because the left hemisphere is being so dominant for speech does seem to have a big role in that process. But it's not really only the left hemisphere that's engaged in that kind of papering over process. It's really the whole brain that's trying to build models of the world and trying to keep them consistent. And yes, some people probably do have models of the world that have very little relation to the actual world itself. And as individuals, it's probably important that we try to incorporate into our motivations constantly keeping some kind of touch with reality, right? Having some kind of contact, having our models of the world continually make contact with reality so they can be corrected by it. It's not an easy thing to do, but it's important that we do it.
Absolutely. Well, taking that a step further, I mean, we're talking about delusion. We're talking about justifying ideas that may not have basis in fact and may not be supported by the information that we are receiving. How often have you come across this type of bias among scientists? Obviously, we have quite a long history of cutting-edge, breaking scientists coming in with new information that contradicts the consensus, and there being huge, sometimes fatal resistance to those new theories based by good data that just happens to contradict all of the old data. I mean, thinking in the historical context and coming up, now into the last 100 years where we're talking about the implications of quantum physics, we're talking about the implications of neuroscience, which is a relatively young science. How much of this do we see in the modern day of science? I mean, is there a lot of bias out there? Is there a lot of delusion? Or would you say, in general, thanks to the method and the inbuilt mechanisms you spoke about before, that generally science is pretty good at updating its beliefs?
It's a really, really good question. I do think in general, it's pretty good at updating its beliefs. And I also think that some of the mechanisms built into the culture of science which reinforce the motivation to not change one's beliefs. So, for example, let's say I come up with a theory and it's a great theory, and we call it let's call it the Freddy theory of the brain, and it becomes really popular. And now I'm known for the Freddy theory, and people are asking me to give talks about the Freddy theory. And some information comes out that contradicts the Freddy theory. Well, I'm certainly benefiting from this theory being correct, and I have the motivation to ignore that evidence and to fight against it. And in some ways, that's not good because I want to be as objective as possible. But sometimes I think, it isn't necessarily the worst problem for science, because every good idea probably deserves a good defense. Right? I mean, we don't want to just give up on any good idea because of the first piece of disconcerting evidence that comes along. It's kind of like your right to a good defense in court. You want a defense attorney who's going to kind of doesn't really care whether you were guilty or not, but is going to give you the best defense possible regardless of that fact. And so there's some value, I think, in having people protect their ideas and to advocate for them, because then those ideas do get the best defense as possible. And in the long run, if they still die, then they weren't really good ideas.
And I think I was speaking more, instead of a sort of an individual theory, I think I was speaking more in terms of consensus. The difficulty when a really ambitious theory comes along, I'm thinking of something maybe like the problems that they're having in quantum gravity theorizations, or reconciling quantum mechanics with the theory of relativity, where it's really contentious. And then someone comes up with something that really just pulls the rug out, as Einstein's theory of relativity did, just pulls the rug out. I mean, there's going to be so much resistance. And I'm just curious how much of this backfire effect and how much of this these kind of phenomena that we're talking about today are active even in the most brilliant scientists who themselves have had to go through that process in their own careers as they started to establish their own ideas and their own consensus. I'm just interested in just how easy it is, particularly with paradigm changing ideas that really upset the consensus. I guess you would call it an age of science or something like that, rather than a paradigm. But what do you think? Do you think that we're in a good shape in general? I guess I'm looking for an overall view. Like, I sort of feel like we're coming to the end of a certain paradigm, and we're going to come back in part 2, Jonas, and talk about consciousness and talk about the self and talk about the implications of various theories of consciousness. Are we in a good position on the whole? I think that would be a nice way to close part 1.
I'm an optimist about that. I think those kinds of paradigm shifts that you're talking about are difficult, and they can be painful, and they can be maybe slower than they should be, but they still happen, right? I mean, it's not like we have the same scientific worldview that we did 100 years ago, or even 30 years ago. I feel like everything changes very rapidly in terms of what the quote unquote consensus is. And I'm not sure even that consensus should be the goal. I mean, there's some degree of diversity of views that's helpful to science. So we should keep that in mind as well.
Healthy debate. Healthy
debate, exactly. And so I think in general, things do seem to move. And there are hiccups, and there are sometimes things catch along the way, but it's not like we're stuck science is not stuck.
Well, that is a great way to close up part 1. So listeners, do please join us for part 2, because we're going to go into other areas of Jonas's research, particularly into identity and self. And I'm really interested in speaking to him about issues of separation and non-separation that we're seeing in quantum physics, and how that might relate to his research into self and identity. And also coming back also to questions of safety and belonging. I really want to speak about that, and really just how the biology of belief affects our physical bodies. I really want to get into this and just find out really how this mind-body connection can be researched, if at all. It's such a controversial question in science. And of course, Chasing Consciousness, we're going to be talking about consciousness. So do please come back for part 2. Hello, listeners, and welcome back to part 2 of this extraordinary interview with Dr. Jonas Kaplan about the Backfire Effect. Please go back to part 1 and take a look at it, where we really dug into the Backfire Effect, into cognitive dissonance, and into the implications of all of this for our post-internet, post-social media world, and how important it is to us to sort of rail in our ability to just completely ignore facts, but at the same time, without completely ignoring our emotional compass that is very important in the way that the mind kind of detects bullshit and stuff as well. So really interesting part 1. Thank you, Jonas. Jonas, I would love to get into the research you've done on self and identity. We define ourselves just so much by our beliefs. It seems really understandable that if something completely challenges our beliefs, that we want to push it away because it threatens our very sense of self and our very sense of identity. I want to relate this to one of the other things that we're exploring, and we're trying to be multidisciplinary in the way we're looking at this. We're looking to separation, the reality of separation at a quantum level. Particularly regarding entanglement of particles. And I'm interested in the fact that there may be this apparent separation at the level of matter, in solids and gases and liquids. But as you get to a subatomic level, we find that in some way that separation is illusory. And I'm interested in how that kind of thinking might apply to a sense of self, and how separate, in fact, we may be from the rest of the world. So bearing all that in mind, just kick us off and tell us about your research into self and identity, and what you concluded from that research.
Illusory, yes. The self is definitely illusory. It doesn't take science to reveal that the self is illusory. You can just do it through introspection. If you spend enough time trying to trace back the origins of your thoughts, you will find that there's really nothing there. There is no central source that thought comes from. And, when neuroscientists have searched for the self or some place in the brain that constitutes the self, there isn't one particular place that constitutes the self. There's the idea that the self, that ourselves is one coherent, unified thing, is definitely an illusion that our brain presents to us. And if we do start thinking about what makes up the self, what are the different parts, we can start to parcelate it a little bit and start to understand some of the neurobiological processes.
Can I jump in and stop you for a moment? Because
Please.
That sounds delightfully big claim. I really like it, and it makes a lot of sense. But first of all, if we're going to say, coming in straight in, the self is illusory, can you define self, just so we know where we stand as the conversation moves forward?
Yes, well, that in itself is a difficult.
Even the definition is illusory.
One of the clues that you're dealing with an illusion is when you have a difficult time defining something,
right?
And this is one of the things that neuroscience does for us is to show us that some of the mental concepts we have, some of the sort of folk psychological concepts we have about the way that we work, don't really stand up to scrutiny. So even if you take a concept like memory, seems like a very obvious, simple thing. I remember things. I know what memory is. But when you start to look at the neuroscience of it, you find out that memory isn't one thing. There are different kinds of memory, right? There's the memory of how to do things. You can learn how to ride a bike, or I can remember facts about the world. And those are two very, very different processes. And the same thing happens when we start to look at the self. It breaks apart under scrutiny. It's not one thing. And so what actually is it? There are a lot of different ways of dividing it up. One of the useful ways, I've been influenced a lot by the writings of Antonio Demasio. When I was in college, I read his book, Descartes' Error. It's a great title. And the error that he was referring to, Descartes believed that the mind was separate from the brain. I know we're going to get into mind-body connections a little bit more in a bit. But Descartes kind of believed that there was this one point of connection between the mind and the brain, one single place in the pineal gland that connected the mind to the brain. And that kind of cohesion is what we're challenging now, that we're going to take apart. I've been fortunate enough now to work with Antonio Demasio. He founded the Brain and Creativity Institute at USC, where I work. And one of the ways that he's described the self is the distinction between the sort of core self, what he calls the core self, and the autobiographical self. So what does that mean? Core self is your perception in the here and now of the physicality of your body. I mean, you are you. You're sitting there. I can see you. There's a part of the screen that's your face, and then part of the screen that's not your face. And so there's a boundary, a physical boundary of your biological body that constitutes yourself in a way. And you have this experience of the internal states of your body at any given time that can be sort of somewhat unconscious or somewhat conscious, depending on your level of attention. But you have this body, and in any given moment, you have a perception of it. Your perception of self would change if your body changed. So, for example, if you were to lose a limb, then your perception of that boundary changes and goes away, and you don't experience having that limb anymore. Maybe you have a phantom limb. That's a whole nother story. But you have this physical body that is in the here and now, and you have information about it that the brain is perceiving. And that is a large part of yourself, is your physical body. It's something biological. Your biology has to decide, where the boundaries of this thing are. But there's another aspect of self which extends across time. You have this idea of who you are, a sense of who you are that's continuous. I'm the same person that I was yesterday. In a lot of senses, I connect myself with the memory of, when I was 7 years old or when I was 20 years old. And there's some continuity there. This is self that extends across time. This is what we call the autobiographical self. And in a lot of ways, it involves stitching together all of these moments of experience that we have of our bodies and of the world. And so there's these ideas of who we are that extend across time that are distinct from the sort of moment-to-moment experiences we have. And if we try to explain the neurobiology of the self, for example, we're going to have to reckon with these two different processes, that there are systems in the brain that are monitoring the internal state of my body, giving me a sense of being a person in space that can change, for example, in out-of-body experiences. And then there are these systems in the brain that are stitching together some kind of coherent interpretation and meaningful explanation of who I am that extends across time, that gives me a personal narrative that is my autobiographical self. Does that make sense?
That is a perfect and almost textbook definition, and yet it's illusory.
It's illusory. I mean, it's illusory in the way, I don't know how far out there we want to go.
Well,
but
we're going way out on this show. We're going to be covering the full spectrum, from the most hardcore materialists to the most extraordinary panpsychists. So please feel free to go as far as your research has taken you.
Well, in some way, all concepts are illusory and are constructions of the mind. So the mind is constantly making distinctions about the world that are useful to the mind. Those distinctions have some basis in reality, but they aren't really necessarily distinctions. They, for example, we divide the world into objects. We have things like the sun as an object, and we think of that as a real thing. But as Alan Watts famously described, that there's no real boundaries to the sun. If you try to find where the light ends, then we're actually within the sun, because the photons from the sun are coming all the way to us. We're also within the heat sphere of the sun. And so that kind of bright ball that we consider to be the boundaries of the sun in our kind of childhood conceptions of it are really an arbitrary line that we've drawn there. Maybe arbitrary is too strong. It's a provisional line. It's useful for some reasons, but it isn't necessarily the end of that thing that's out there. And the same thing is true of the self, that there are no real actual boundaries to it. I mean, if you think about the stuff that, let's take the physical self, the moment-to-moment experience of my body as a thing, as a consistent thing. My body is not a consistent thing. I mean, it changes in size and shape. My cells, the cells that make up the body, are constantly turning over. There may be no single cell in my body that I was born with. I don't know if that's true or not, but there's certainly a lot of me is not the same. And we constantly incorporating food and gases from the outside world. I mean, as I sit here, I'm taking in oxygen from around me that's being incorporated into my physical self and exhaling carbon dioxide. I mean, you're seeing the dynamics of myself before your very eyes, and you don't even notice it. So the consistency of even the physical body is something of an illusion and a provisional concept that the brain uses because it's useful. It helps us take care of ourselves. Certainly, the autobiographical self is an illusion as well. The consistency that we have across time is something that we impose. It's an interpretation we impose on reality.
So how does that relate to some of the findings of quantum physics? I know this isn't necessarily your field, but does this idea of potentially there being a non-separation at a subatomic level, does that resonate with you? And is there anything in your research into self that has revealed anything of this kind, or some element of kind of a blur between selves or between self and other?
There's definitely a blur between self and other, and that we can experience differently at different times. I mean, we're talking about the human self, but it may also be interesting to talk about the selves that occupy different forms of biology. And in biology, there seem to be a range of separation between individuals in the way that biological systems are organized. So we experience our individuality very strongly most of the time. But there are other animals where the distinctions, or other life forms where the distinctions are not so clear. So if you look at something like a colony of wasps, it looks to be acting as a coherent sort of superorganism. And the individuals do have individual roles, but often they're willing to die for the group. And that's a clear case where the boundaries of the self become kind of blurrier. Is the boundaries of the self really at the physical end of each individual organism, or are they at the sort of collective intention of the thing working together? And humans live in this kind of gray area where we often experience ourselves very individualistically as individual units. And then there are times in which we're able to sort of experience ourselves differently and to feel more part of something bigger, part of a bigger cause. There are causes that people are willing to sacrifice themselves for example. And so the experience of the self as a human is very fluid and changes between these different dimensions. And of course, you mentioned the Buddha. There are things that people can do that change their conscious experience of the self. You can do things like meditation or psychedelic drugs, for example, can radically change the experience of the self by just changing your neurobiology a little bit. So the experience of the self is not one static thing as a human. It kind of is able to move between those poles. And I think that shows us a little bit about the illusory nature of it. And that it really is a temporary perception that we have.
And how did you set about experimenting with this? How did you set up your experiments to look into it?
We've looked into it in a number of ways. So earlier in my career, I did examine the split brain that we talked about briefly, where it seems that there are two selves in one head. It's a very strange situation, but because the left and right hemisphere of the brain aren't talking to each other, they have their own private information, they seem to be two separate selves. And so we would probe those two hemispheres separately to see what we could learn about the two different cells and how they were integrated. Later in my career, I've used neuroimaging. So one of the things we do is we ask people to think about themselves. So while they're in the fMRI scanner, we ask them to think about, what kind of person are you? Are you a good person? Are you an honest person? Are you a lazy person? And when you're doing that kind of thought process, thinking about yourself, what's happening in the brain that's different when you think about someone else? So if I think about, is Freddie an honest person? It's a different mental process there. And what can we learn about the brain from engaging those different kinds of self-perceptive processes?
Any conclusions?
Well, this is where the default mode network comes up again. We do find that when people think about themselves a lot, they are engaging this default mode network. And we're not sure exactly, again, what it is. That a lot of people thought originally that this was a self-related network in the brain that's really for thinking about yourself. I think it probably has a much more basic process that generalizes to a lot of different cognitive operations, some of which are involved in thinking about yourself, but are probably involved in thinking about stories in general and making sense of the world in a narrative way.
And we're going to come on to that in a minute. You've also looked into social group membership, and in part one, we discussed, listeners, we discussed about belonging as being a very, very important element in terms of the way we structure our beliefs. It may well be a question of trying to fit in and making sure that we are safe within our social group. What were you researching when you looked into that?
Well, social group membership is so important. I mean, a large part of how we define ourselves is by our social group membership. And so we've looked at lots of different ways in which social group membership can influence the way that the brain functions. For example, politics is one of the things that we studied quite a bit. How do you think about the politician who's on your own side versus a politician who's on the other side? It's one of these ways we divide ourselves into tribes, and there are very specific emotional feelings associated with thinking about someone who's part of your tribe versus someone who isn't part of your tribe. And that's one of the things that we look into. Certainly, with our belief research, it's important because we share beliefs with people that we're connected to, and one of the things we're asking people to do when we're asking them to change their minds is to change both their connections with other people and how other people think of them. So one thing that often happens in our experiments, when we ask people to consider evidence that challenges their beliefs, is they'll say things like, well, I can't change my mind about that. Like, what would my friends think of me if I suddenly was in favor of limiting abortion, for example? This is something that people think about all the time. It is involved in so many cognitive operations that we do. We're thinking about what other people are going to think of us. This is an aspect of the self that is, we're constantly representing others' views of ourselves.
And it certainly begs the question about just how interdependent we are with that social group, not only in a sense of identity, but actually in terms of actually free will. We're not going to go into free will today because it's a big discussion, but it's just in terms of being separate from other members of my community. There's a lot of questions there, isn't there? And what about this kind of mammalian psychology about fight or flight and the stimulus into emotions that we touched on in the first part? Presumably, that is very, very important as well in terms of feeling safe in my community, and that therefore allowing me to reason and to assess the world in a calm and sort of grounded and rational way. Presumably that's at play in the self and in our sense of identity as well.
Yeah, I mean, hopefully that's one of the things that community provides people, is a sense of safety and connection. We also study empathy is one of the ways in which we study this, to see how we resonate with other people. And, one of the things we find in the brain relates to this idea of what you're getting at, that we're really connected with our community members in a very physical and real way, that we aren't separate. And that is the phenomenon of mirror neurons. So this is one of the things that I've studied in the past, is how people understand what other people are doing. When you look at somebody acting, what's happening in your own mind, in your own brain, that allows you to understand what they're doing. And what we find is that the brain is unconsciously simulating everything that everyone else is doing. So when I look into your brain, and we look at the motor cortex, for example, the motor cortex is the part of your brain that controls your movements. So if I'm going to move my arm, you're going to see activity in my premotor cortex. But what's interesting is that when I see you move your arm, you're also going to see activity in my motor cortex. It's as if I'm rehearsing the act that I'm watching you do. So this is one of the ways we understand each other, is by simulating what everyone else is doing. And if you think about it, that gives you a very real connection to my brain. When you're moving around, you're actually moving and activating my own motor cortex in a very specific way that allows me to understand you. This is a general principle of brain function. It's not just with motor function. So we see it with emotions. We see it with touch experiences. We've been able to look into the brain and tell from the somatosensory cortex is the part of the brain that controls touch. We can tell from the patterns of activity in the somatosensory cortex what kind of touch you're watching someone else experience. So these experiences we have, these resonances we have between each other are very, very strong, and our brains are interconnected.
Okay, great. So we've looked into the self from that point of view. I know you're interested in narrative. Now, one of the things that I'm interested in, we'll be exploring on here, is not only mythopoetry and sort of Joseph Campbell's research into this idea of the human condition being reflected very meaningfully in story, perhaps more meaningfully than any fact we can garner through scientific method. And it seems to really bring humans into an engagement and into a belief much more effectively, strangely, than the fact that we're discussing. How important are stories to the way we define ourselves, the way we belong, and the way we are individuated as people within those communities?
Yeah, I think in a lot of ways, stories are likely to be at the very center of all of these topics that we're talking about: our connection with our community, our understanding of ourself, our perception of the world. I think narrative is one of the main mechanisms that the brain uses to organize information about the world. And the brain has this difficult job of taking in tremendous amount of information at any given time. We've all the senses rolling in on us. We've got tons of visual information, auditory information. We have information from our memories and our thoughts and what other people are saying. It's a tremendous amount of information that requires us to integrate and understand and create some kind of meaningful, understandable model of what's going on. And I think narratives are that model. Narratives are the form in which we store information. Your memory has this episodic nature to it. If you try to remember, you tell somebody what happened yesterday, it's not going to be a series of unrelated events. It's going to be a story where there's cause and effect, and there's some kind of meaning or gist or intentionality to the whole thing. So narrative is central to the way we organize information about the world, and ourselves, being part of that world, are also subject to that kind of narrative organization of information. And that's why I think, when we look into the brain, when we're looking at processes that we're looking at what happens when people think about themselves. We're seeing very similar patterns of activity to when people just listen to stories and process stories. So we've done some brain experiments now where we look at what's happening when people listen to someone tell a story on a podcast. And we have a bunch of data that we're analyzing from that now. It looks very much like what happens when people think about themselves. And these stories also help to encapsulate our values, our deepest beliefs and values are kind of packaged into stories. And then these packages become the means of communication as well, the means of spreading. So when we interact with community members, we tell stories to each other. Storytelling is one of the oldest human activities. There's some really interesting research showing that storytelling really came on in human history when we started to build fires at night. And so we had the day extended beyond the time in which we could engage in useful, externally focused activities. During the day, you can go about your farming, you can talk to people, you can conduct business, whatever it is that you do. But at night, when it's totally dark and everyone's sitting around this fire, and all we have is the glow of our faces, our minds are free to turn to other times and places. And that's when people start telling stories and telling stories that are myths or just funny stories or things that happened yesterday. And I think it's interesting that we still tell stories in this way. We watching movies is one of the favorite things our culture likes to do. We all sit in a dark theater together in the flicker of the projector in front of us. So this kind of storytelling is something that's deep within our history, and that we're still drawn to, like moths.
And what was that research about? Do you remember the name of the researcher? It sounds right up my street.
Yes, I could find it for you. She was studying the hunter-gatherer tribes in Africa, who still sort of have that format to their day, where they're going about their business during the day. And what she did was she studied the content of their communications during the day versus at night when they were sitting around the fire. And the proportion of their speech that turns to stories at night is just overwhelming.
Interesting. How does that affect our sense of self?
Well, our sense of self is a story. A lot of it is a story. It's a story that we tell to ourselves. It's a story that we tell to other people, and we share it. And that's why I think, that's why I think when we learn to separate our thought from our sense of self, as we do in meditation, that really what we're doing is kind of quieting this narrative process that we have in general in the mind, that instead of constantly interpret everything and forming all the information into little stories and forming ourself into a story, we can kind of release our thought process from that storytelling, and then we're left with a bunch of individual impressions that don't have the same kind of meaning or weight to us.
So it kind of gives us a defining function, probably in that same area of the brain that you keep talking about, what's it called, default mode network.
Yeah.
That almost certainly this is it's a way of saying this is who I am. And do you think there's a safety element there, that it's sort of like, if I know who I am, if I feel like I can identify, then I feel safe? I mean, I know that in a lot of psychedelic research, they find that there is this point where the ego is at risk of completely dissolving, and that is a moment of absolute terror for people, because there's just this idea of, my God, I'm not coming back, and they're going to lose their self. So I wonder if this attraction and attachment to our stories, both in terms of our memories, in terms of feeling like I'm alive, I'm here, I'm playing a part, is connected to this desperate need to know that we really exist and that we are here and that we are safe.
Yeah, you're right. Ego death is terrifying. And, I think part of the reason it's so terrifying is because even though the self is an illusion, we believe the illusion. It's a very, very convincing illusion. We become attached to that story, and we think it's really who we are. And therefore, if we let go of it, if it dies, if it goes away, then we're dying. And so the fear of ego death is very much the same as the fear of death. I mean, if you identify with that story, if you really connect with it and you feel that that's you, then letting it go away is the same as really dying, as letting your actual self go. And I think that the brain convinces itself that this story is who I am. Then it feels like it's letting itself die if it lets go. Of course, people don't actually die when they go through these psychedelic experiences. It can be scary at first, but then there's usually some great insight associated with it, right? Once you see beyond this story, you see it as an illusion. There's what you're left with is a connection with everything else. That the entire world is what you're connected to, instead of this story of yourself.
And that brings me back to the non-separation question that quantum physics seems to be ever more urging us towards. If we have reports from psychonauts about this, some form of sort of amalgamous, interconnected mass, both, including matter and consciousness, we have reports from ancient mystics, and we now have modern science bringing us in this direction that at a subatomic level, these separations may be illusory. What are your thoughts on that? Do you think that there is a chance that not only the self is illusory, but actual physical separateness in the physical world is illusory, or is that going a step too far?
Not necessarily. I think that's probably true. And I think in the sort of moments of deepest insight, we might connect with that perspective. But then, as in the case of ego death and psychedelics, what happens is that eventually your ego recoheres and you come back to the world. And in order to function in the world, you do have to have some kind of coherent self. Once we pull back from that insight that maybe everything in the world is connected in terms of physics, then we also can see the usefulness of making the distinctions that we make, right? Mm-hmm. We understand electrons as separate from protons, for example. There are things that we can do with chemistry because of that understanding, that make it a useful provisional distinction, even though we might have a deeper insight underneath that these things are connected.
Well, and I'm starting to think of it almost as a two-tier world where, at the same time as being separate, things are in fact all interconnected at the same time. And I don't see necessarily there being a problem of a two-tiered physics, although we may have some philosophical issues with that. And that brings us nicely onto the mind-body connection, another extremely controversial thing in biology and in psychology. I couldn't help notice that on your website, you've called your research into beliefs the biology of belief, and that happens to be the same title as a book by a famous epigeneticist and kind of new age microbiologist, Bruce Lipton, who left science after he got a little bit frustrated with the fact that certain implications of epigenetics weren't really being brought forward in terms of sort of what we can actually do with that as people. And I'm hoping this podcast can help the general public do that, try and take some of these implications of the work forward. So in the book, he's arguing that as the environment is all important to the epigenetic changes that we see in the body throughout our lives, so the attitude of our mind and our beliefs, as we've been discussing today, is an environmental factor and would therefore have a direct influence on our epigenetic evolution and biological development. Has your research shed any light on this mind-body connection possibility? And do you tend to agree with claims such as Lipton's, or do you think the research still has a long way to go before we can establish a clear link between the biological elements that we see in the physical world and our state of mind?
Well, in one sense, they're clearly linked, and in many in neuroscience would say, in fact, they're identical. That the mind is identical with some biological function. We don't need to get into the philosophy of mind of that whole thing, but I don't think there's any.
The buzzword in neuroscience, correlated, isn't it?
Yeah, correlated is sort of the strongest claim that we can often make. Although most neuroscientists, if you press them, will say that they have a stronger belief than that. That what happens in the mind and what happens in the brain aren't just correlated. That they really are two sides of the same coin. And so in that sense, we obviously they're linked. If you destroy parts of the brain, you destroy parts of the mind. So and the brain certainly has effects on the body. What the brain and what the mind do can have all kinds of effects. If we're thinking thoughts that make us feel more stressed, for example, you're going to see increases in stress hormones, and that's going to have long-term effects on the body. And we know a lot from psychology that certain states of mind can be associated with states of the body. So depression is associated with increased inflammation. And there are certainly all kinds of biological processes that are directly linked to our thoughts and to what we think. As to the particular theory that you're talking about, I'm not really familiar with his work, although I'd say my general orientation towards the idea that the mental functioning could directly affect genetic expression elsewhere in the body is skeptical. So I'd have to see the specific evidence for that, but it's certainly not out of the question. And I just don't actually know the science on that.
Yeah, and I think it's come a long way, and it certainly sounds like there's a lot of places where we can kind of trace a connection. Do you think this is becoming more mainstream now in psychology and in biology, this understanding that we can directly influence biology using our minds, and perhaps vice versa? You know, I can attest to it, having done a bit of a detox during the lockdown, that there was a remarkable change in my psychology from just changing my physical habits and my nutrition.
Yeah, I think this is something that people are coming more and more to expect. You know, one of the strange issues we have in science is the division of labor that we have among all the different disciplines. You know, we kind of divide up the world into the study of different things, and then that division leads to people thinking only within those boxes. So we have medical science, doctors that study a well-being of the body, and we have psychologists who study the mind, and maybe psychiatrists who are studying it from a pharmacological perspective. And I think there's a lot of downsides to that kind of isolation of disciplines. But it's starting to erode a little bit. I think medical doctors are starting to understand a little bit more of the effects that psychology have on the body, and are starting to have a more psychological perspective on things. And psychologists as well are understanding the effects of the body on the brain. I mean, you know, one of the best treatments for depression is physical exercise. So
are we starting to see studies actually being conducted by teams of biologists and neuroscientists coming together and actually literally trying to create experiments on the same page, as it were?
Oh, yeah, absolutely. There's a lot of interdisciplinary research across. I mean, science is so hard now that you can't do it without a team of people. And so it's probably more common than not to have that kind of a team.
Well, it's more the interdisciplinary approach that I think is really overdue. You know, we just really need to start linking up all of these bits of research. And, you know, I'm sure that the tendency towards open source databases and, starting to post more negative results and just all of this stuff is just going to create more and more intercollaboration between these various disciplines. But also for us as the public and philosophers in general, trying to get a sense of what are the implications of all of these different areas of research as a whole for us as a society, actually looking for genuine solutions. Well, Jonas, I shan't press you anymore. Thank you so much, not only for sharing some of your research with us, but doing it in such an eloquent way, because it is really these really fundamental issues are so important to who we are. And I think for psychology, not just to be looking for solutions to mental health, but actually to looking to understand who we are as people and in our communities. I think it's great to see some science that's sort of more constructive in that sense, rather than just looking to problem solve as so much science is. So thank you very much. I understand you're also going to be launching a podcast yourself soon. Do you want to tell the listeners about that? I mean, obviously it's
it's early. We're working on that. We don't even have a title yet, but this is something that I'm doing with my friend Mary Sweeney, who is a film editor, and she's interested. You know, it turns out that we talked about interdisciplinary work, that mixing people from different fields of science. But I think that actually having science come up against different artistic endeavors is also really important, because art is just another way that we use to understand humanity and the human experience. And there's so many things that artists think about that are so similar to what we think about as neuroscientists. And my discussions with Mary as a filmmaker have uncovered that filmmakers and cognitive neuroscientists are in a lot of ways doing the same work with different tools. And so our podcast is going to explore that by talking to people from both worlds.
Well, keep an eye on Jonas's website to learn more about that and to understand more of his research, which is ever evolving. Jonas, thank you once again for all of your insight. All the best.
Thank you. All right. Take care.